In the previous van tour episode, you get a general overview of the vehicle, but this time I'd like to dive into the technical side of the things. So how the electrical system is set up, how heating, cooling, the water system and other technical aspects of the van work. So let's get into it, starting with the water and the heating systems. On this previously mentioned panel, these three vents are responsible for cooling, and this one and this one are for heating. With these mechanical switches, we can control what happens to the hot air. Let's go over how all of this works. First, let's take a look at the heating system. There's a diesel heater in the vehicle, and I split the airflow from it into two branches. The upper branch contains a heat exchanger, while the lower branch is a bypass line that skips the heat exchanger. The amount of air going into each branch can be controlled with these two switches. I'll explain shortly why this seemingly unnecessary bypass exists. After this, the two pipes merge again, then split once more. Using two additional valves, the hot air can be directed either to the shower or to the living area, and these switches here allow you to control that. Let's continue with the heat exchanger. The heat exchanger system is a separate closed loop where a pump circulates the water. There's also a 60-liter tank that contains the secondary part of the heat exchanger. This is where the heat is transferred. This tank is responsible for storing the shower water. The bypass valve below is necessary because the heat exchanger system is not designed to handle pressure. If I were to send several 100-degree hot air into it while the circulation pump isn't running, for instance, if I don't want to heat the shower water, it would eventually explode somewhere in the system. It's important to note that this is the most compact camper build I could possibly create. At this level, there's no room for fancy solutions, everything has to be packed into the smallest possible place. Also, I constantly tweak and adjust the systems in the van, so things are always changing. That's why I don't really like permanent solutions. From the shower water tank, a pump directly delivers hot water to the shower. Another pump draws used water from the shower drain, and with the help of a valve we can do two things with it. Either send it to the grey water tank or recirculate it within the system. If we choose to recirculate it, the water first passes through three mechanical filters, then an UV filter for further purification, and finally it returns to the shower water tank. The shower water tank can also be refilled from the freshwater tanks, which each have a capacity of 80 liters. Refilling is done with the help of a pump. This line is split by a valve, and some of the water is also directed to the kitchen sink. The sink's wastewater is likewise routed into the grey water tank. If you are interested in van building or our travels, don't forget to subscribe to the channel. That's all about the heating and water system. Cooling is provided by a Truma Zephyr compact floor-mounted air conditioner. And now let's talk about the electrical systems. I won't show a schematic diagram here. Instead, I'll go through each component one by one. First of all, there's a 4G router for mobile network access. There are a few buck converters scattered around, you can see some of them here. This is the external 220-volt fuse box equipped with a RCD for safety and a double-pole circuit breaker. The solar system has two separate circuits, so I'm using two Victron MPPT charge controllers. Even this setup is still a bottleneck compared to the solar panels, so I will be upgrading it soon. There's also a few distribution panels with circuit breakers. In addition, there's a Victron Orion TR Smart DC-DC charger which charges the batteries from the vehicle's alternator. Over here you can see a Victron Blue Smart charger which charges the batteries from an external 220-volt power source. Here is the battery isolation switch. By the way, the van is equipped with three 200 Ah lithium iron phosphate batteries located down here. On top of that, there's a smart battery sense temperature sensor and a smart shunt for current measurements. There's also a 3000 watt energy inverter and the dual pole circuit breakers for the solar panels. Lastly, here's a remote-controlled relay panel, which can be operated from a control unit in the driver's cabin. At the moment, it's used to control the exterior-mounted floodlights. There's also another DC-DC converter here. If you are into technical content like this or curious about our road trips, make sure to subscribe to the channel and don't forget to check us out on Instagram too. So thanks for watching, bye!